start. So I will hand it over to our program director. And just quickly before I do that, we do have our student services team on today. So if you have any questions for them, please feel free to answer, or please feel free to ask. And we also have one of our student ambassadors. So I'll hand it over to you, Rolando.
Thank you. Thank you very much. Welcome everyone. And you can see my slides, right?
Yes.
Fantastic. Welcome everyone. Thank you for joining. So my name is Rolando Herrero. I run two programs, the telecom networks and the physical systems. That's my email address. As usual, you can send me an email whenever you feel like, if you have a question or you concern, questions, comments, you can reach out to me. I normally get back to you within 24 hours. If I don't get back to you, it means I did not get your email, and you should send it again. I will reply even to tell you I got your email. So I'll talk briefly about the programs. You may have seen similar information before in one of the Wonder Weeks or the open houses that we have in the past. Again, I'm briefly going to talk about them. I'm going to also talk about the classes, the offerings, what you should be registering for in the fall, and basically some additional information. So that's the overall idea for today. This is not an orientation like the one we typically have at the beginning of the fall, as you are physically joining the program. This is mostly a mix between the orientation and our traditional webinars that we do to potential students, right? So it's a mix. With that, right, so let's start talking about, and again, this applies to telecommunication networks. So telecommunication networks is only taught in Boston. So telecommunication networks in Boston, physical systems in Boston and Toronto. So basically two programs, and one of the programs has two different locations where it is offered. So the first program I want to talk about very briefly again is the Telecommunication Network program. So this is a program that started back in the late 90s, beginning of the 2000s with the internet revolution. And through the years, I had a lot of graduates, especially around 1,000 graduates since 2004. Actually, that's when the program actually physically started. It's one of the two telecom programs in US. And a lot of the graduates end up working in the US in big companies, corporations, but also startups. Again, this has one of the best co-op placement rates in the College of Engineering. And as I said, it's only available in the Boston campus only. And through the years, telecom networks started from being very, very different distributed systems with different protocols, technologies, and standards into something that now is very internet-centric, right? So internet is at the heart of every single protocol and standard that you use in telecom. So this program, because of that, and because it's very dynamic and follows what the industry wants, it's very centric on the internet too, right? So our focus is on networking and in internet-based protocols and technologies. And this basically leads with not only internet, but mobile networks, content networks, IoT, Internet of Things, data centers, enterprises, transport networks, right? Even these days, when you do communications, fiber optic communications between different locations geographically, you still use internet protocols, which was not the case, like, let's say, 15 years ago, right? So networking and telecom are exciting areas, a lot of different stuff that is basically driven by the internet and telecom. And as I mentioned, all these different areas, anything from software-defined networks to IoT and so on, right? So this leads typically to good jobs. There is not a lot of competition, program-wise. So the job market is in general fairly good, even when there are tough market conditions. So this program is focused on industry. It's not a research degree program, so this is not your master's in electrical engineering or computer science. You're not going to be writing mathematical models to model telecommunication networks. You're going to be building those networks. That's the main differentiator, right? So it has again a focus on industry. And as I said, it's located in Boston, which basically has, access to, faculty and people working in the industry. Is in an area that is central to telecommunications. Right. So the program content covers a lot of areas. Again, anything from, software-defined networks, IoT, 5G, and so on. The big, and this is something I always tell students, it's not like it was 20 years ago. Now there is a heavy component of software. So we call this softwareization. So most of telecommunication network jobs and telecommunication networks deployments and anything related to telecommunication networks requires you to have software skills, even if it is just to understand code, right? These days, with a lot of the tools out there, AI tools, you can have code being generated for you, but you still need to have certain architectural skills that unfortunately AI cannot do, right? So that's basically very key here, right? So software development is very, very important. So that we have a lot of electives and classes that you can take, not only within the telecommunication program, but outside the telecommunication programs under the MChen, which is our unit, and even then outside the MChen unit in electrical engineering, computer science, and even in business if needed, right? So we basically try to give you the best possibilities to take advantage of the job market. So most of the classes in the telecommunications programs are, I would say it's not all, they're project oriented. So it's pretty much hands-on learning, right? And again, all of this leads to making you be in a good shape for co-ops and graduate market after, or for the job market after graduation. Right. So let's talk about the actual classes. So you need only 8 classes, 32 credits in 2 years. This is great because that means you need to take only 2 classes per semester. You may think that that doesn't sound like a lot, right? But these are intensive classes. A lot of stuff is hands-on. I would say all of it is hands-on. So they're time consuming, right? So, but at the same time, it's even then, 2 classes give you extra time to do other things, right? The other thing you don't need to have, unless you want to, is the thesis or project requirements. So there are no thesis or project requirements unless you want to, right? So we do offer, 2 classes that piggyback with each other. One is the master project, the other one is the master thesis, in which what you do is when you graduate, you have essentially a defense, and you end up getting a thesis like you get in any other master program. But again, this is up to you. I mean, it's optional. Some students want to do that. Some other students don't, right? Some of them want to prefer to take classes instead of doing those that master thesis option. Some others just want to do the master project, which is essentially like a capstone project without the thesis, right? So all those are possibilities. The bottom line is besides those, you have a lot of classes you can take, elective classes from the telecom program, from outside the telecom program within the MChen division, which is where we are. We're talking about hundreds of classes you can take. And beyond that, classes in electrical engineering, in computer science, and even, depending on your interest, stuff on management, engineer management, and project management, for example, which is very popular. So those are classes you can take, right? Again, we try to tailor the program to your needs and the market needs. And if we have those classes available, I mean, and you're interested and makes sense for your career, you can take them. So, but let's talk about the core classes, right? So I mentioned there are 3 core classes, 5 elective classes. Those 3 core classes are data networking, telecom and network infrastructure, and internet protocols and architecture. If you are starting the fall, our recommendation is for you to register because one of the things you want to do is you want to finish with your core classes as soon as possible so you can take your elective. So in the first semester, just takes data networking. That will give you a very good introduction to internet technologies and data networking architectures. It's not the it's like an initial class you need to take for that. I mean, in addition to those, there are other classes you will be taking as core, like you see here, Internet Protocols and Architecture. But essentially, for the first semester, you take data networking. You should register for data networking, and for telecom and network infrastructure, which leads essentially with the actual topologies, and in particular with the bigger picture in the context of telecommunication networks, right? So how do you do wireless connectivity, cellular connectivity, how do you connect do fiber optic connectivity, and all of that. So those Tele 5330 and 5350 are the recommendations for you to register in the first semester. Besides that, we have many other classes. Again, I'm not going to go through the list, but you can see it here. Anything dealing with communications itself, and also software, right? Because as I mentioned, software is very important. Everything is driven through software, in particular because of the automation, right? So we telecommunication networks are about automation, so there is very little manual interaction, and the way you do that is through writing code. And regardless of how you write the code, you need to understand it, right? And so therefore, software electives are very important. Right, so that's from the perspective of telecom networks. That's that's the biggest insight I can give you. Now, for the important, if there is something you need to remember, and eventually, if you're registering for the fall, remember you need to register for 5330 and 5350. Right, those two classes are the recommended classes for registration. Now, let's talk do the same about the Cyber Physical Systems program. So Cyber Physical Systems is a term that is fairly new. I would say it's probably 10 years old. It's basically a combination of cyber and physical components, right? Physical is what happens in the human world. This is where you interact with things. We interact with what we call assets in the environment, and you can think of the asset as anything that is there, right? You can think of the asset as a warehouse, right? And the warehouse, you want to measure the temperature because you want to check whether there is, for example, a fire in the warehouse, which will cause a big problem, right? So in the cyber physical systems, your physical component is your those assets that interact with the environment. Now, in addition, you have a virtual world. That's the cyber world, right? So this is a world where you have the automation, and you do this automation to say by means of AI, essentially artificial intelligence mechanisms, right? So cyber physical systems is about combining the physical world with the virtual world and using IoT technologies to combine both. Within that spectrum, you have a lot of stuff, right? You have security, cybersecurity. You have, again, IoT protocols, which are internet-based protocols used for the communication between AI and those physical assets. And the interaction with those physical assets is through sensing and actuation. So cyber physical systems is about that. It's essentially like a superset of telecom networks in which besides the telecom components of IoT, you now take into account the devices that you need to interact with the environment, essentially sensors, actuators, and the AI, you need to process that sensor and actuation data. And again, it's very telecom centric because you need a standardization, and that's done with what we call IoT or Internet of Things protocols. Now, this is a fairly new trend because until now you didn't have the capabilities to do this, to support this automation. One of the big things we have now is chip electronics. We have really good AI mechanisms, which you can handle because you have chip electronics, which give you a lot of computational capabilities at very low cost. Which enables you to replace essentially the human asset interaction now with essentially machine asset interaction, right? So this has led to all kinds of scenarios for automation, anything from industrial manufacturing. This is what they call smart manufacturing, which is a manufacturing of the future, where your factories are basically humanless, are pretty much running on electronics and machines alone with very little human interaction, to stuff like this, more human-centric, like vehicle to infrastructure communication, where humans don't drive anymore, and basically machines drive for them, right? So all of that, those are examples of cyber-physical systems, besides other things like connected health, home automation, building automation, and so on. All those things is systems in which we replace a lot of the interaction that typically humans will do with machines in such a way that you can have safer systems with fewer errors and fewer emergencies. Right. So that's the focus of this program. So these three areas, which is essentially the devices, the AI, and the networks, are the focus of this program. So we typically, the way we handle this is when you're in cyber physical systems, depending on your interests, you can take classes that are more oriented to a certain area than others, right? So the goal here is for you to take some core classes that are generic enough that in the long term will enable you to follow any one of these tracks. These tracks are not mandatory in the sense that you don't need to say I'm on this particular track. It's basically for you to know what you should be taking class-wise to align with those job market needs, right? Because typically what happens is there are companies that work on AI. They typically do the cyber part, but they don't do the physical part. And the same way, there are companies that focus on the physical part, but they don't do the AI part. So based on that, you can have, based on your interest and where you want to go career-wise, for example, if your background is in computer science or IT, you're probably more geared towards AI, while if your background is in electrical engineering, you're probably more geared toward smart device development, right? And that's typically what we see student-wise. The cyber system program, as I said, is offered in Boston and Toronto. But basically, both those cities are very, very important in the context of cyber systems. We have a lot of interaction with the companies. We basically have a club that we call the IoT Connect Club. We have membership to standardization bodies. In Boston, we have a lab which covers telecom and cyber systems. Again, it's for both programs. This lab has all the hardware and everything you need to, for example, take your classes, do projects on the side, basically support all that interaction with the physical environment that you need, right? In addition, again, as in the telecom program, you can take classes outside the cyber physical system program to support your interests and needs, right? And again, this is tied also to the co-op program, which is fairly strong. This is a few details of our lab here in Boston. As you can see, we basically have this lab in the 5th floor of Dana. Opened in the fall last year, supports teleclasses, supports applied research and external funding, and supports industry events and hackathons. We participated in several industry events, and now in the fall we're going to be having a hackathon, which is the Hackathons, a hackathon. This should be in the fall 25. We're still, coming up with the details for that. So a few details about the program. So you basically have 4 core classes, from which one is IoT, one is IoT, essentially IoT telecom specific, one is application specific, one is device specific. So one is AI specific, the other one is device development specific. We have a 4th class, which is more on the programming side. If you are already familiar with software development, your best bet is to focus on taking either one of those, taking these 3 classes for your core. Although you only need 2 for the core, selecting 2 out of these 3, right? So we basically have a great flexibility. All the classes, as in the case of telecom, is project-oriented. Again, our program is industry-oriented. This is not, and I repeat, this is not your master's in electrical engineering, where you're going to be building, the mathematical models, right? So here you're going to be building systems. So the requirements are, again, 8 classes. over 2 years, essentially 2 classes per semester, same concept. These classes are, again, they're not lightweight. It's 2 classes per semester, but they're not lightweight classes. We have 2 required core classes. One is called Fundamentals of IoT. The other one is Connected Devices. On the and let me clarify, because maybe I was a bit confusing before. On the elective side, you need to choose 2 out of these 3. And as I said, there is one with focus on AI, one with focus on embedded device development, essentially with the devices, and another one with focus on software development, which again, that's a good class to get up to speed with software development. What we recommend is for the fall semester this year, if you're in Boston, take Fundamentals of IoT. And by the way, keep some of these classes are available on certain semesters and others are not. So depending on that, that's our recommendation. And that depends on location too. That's why we recommend certain things with the idea of you finishing with your core classes as soon as possible. So if you're in Boston, we recommend you take Fundamentals of IoT and either machine learning for IoT or smart device development. Because, for example, one of these is only offered in the fall. And if you're in Toronto, we recommend you take Fundamentals of IoT and Info 5100 Application Engineering Development. Those are the ones we recommend, right? Besides then, that you can take other electives later on, right? There is no requirement for thesis with project in Boston. There is a requirement in Toronto for a capstone project, essentially for our master project class. That should be done the last semester, right? Before, we have a lot of electives. The difference here with telecom, in which our focus is on telecom networks, communications, and software. Here, the focus is more on the smart devices, on the smart applications, essentially in AI, and also on the IoT protocols, right? So our focus is slightly different, but we essentially have all these different classes, okay? And so we have faculty that is both in academia and also in industry. We have a lot of faculty that work actively in industry, which is really good. You typically wouldn't see that in a program like a master's in electrical engineering, where mostly the faculty is academia based. Here you have a mix, academia and industry. So you get an insight of what's going on in the industry, right? Again, you would not get that in any other program, but you get it here. So, but that doesn't mean our faculty is not really on the R&D side. So a lot of our faculty have written books. A lot of books are being used not only by Northeastern, by other universities around the world. So we have a lot of innovation provided by our faculty. We have an industry board, a lot of industries and companies, startups and companies that collaborate with us, providing guidelines on how the program should be structured, what classes we should have, what our focus should be. You already know the admission criteria. We do have our industry co-op. I'm not going to go through the industry admission criteria because you guys are probably familiar with it. And since you're here, you probably met it already. So the industry co-op, the goal is to support internships, and typically is done through your time at university, depending on the situation, it could be 4, 6, or 8 months. One important thing is in order to go into your co-op, if you are interested in, and this in particular is important for international students, you need to take your one credit course, which is called the ENCP 6000, Career Management for Engineers. So this class, Career Management for Engineers, you typically is a one credit class that you take in your first semester, along with the other 2 classes I mentioned, right? So you take this ENCP 6000, and then the following, after you're done with the class, so if you start in the fall, I would say by the summer, you could go into a co-op, right? Again, when you go into the orientation in the fall, you're going to have a lot more information in regards to the co-op and the requirements and how it works and so on. This is a quick overview, but important things you need if you're interested in a co-op and your next semester you're starting in fall, you need to register for ENCP 6000 along with the other two classes we recommend. And see, so this is, by the way, the schedule for co-ops. This is typically how it works. So depending where it starts, depending on the duration, that's between you and the company, and this is when it finishes, right? And students that have gone in co-ops have gone in all kind of companies, like the ones shown up here. One important thing is, and many students don't think of this, is the co-op requirements are very, very strong requirements. So it's very difficult to bend the rules. So you need to keep a good GPA above 3.2. You need to have completed the ENCP 6000 per passing grade. You need to have completed at least 16 credits. That means you can only start your co-op. If you start in the fall, your co-op can start in the summer of the following year, right? So in your case would be summer 26. Okay. So that's basically related to co-ops. So for staff supporting your program, you have me, as I mentioned. My participation is more on the academic area from a perspective of what should I be doing if these are my career goals. Let's say you're interested in a physical system from a perspective of cybersecurity or perspective of robotics, right? So what classes should I be taking as electives? So that's the kind of questions I can answer. Oh, so where should I be? I want to get into the job market, right? And I'm interested in working in this or that, right? So what should be my career path? What type of company should I be targeting and so on? So I am here to help you with that. If, on the other hand, you have questions specific to the program dynamics, like, for example, I'm taking this class and this other class, will this prevent me from graduating when I want to graduate? That's something the academic advising teams can answer, right? And basically, depending on whether you're in Boston or Toronto, you have two different emails you have to use to reach out. One is for student services in Boston, in which case you reach out to this second email right here. And if you're in Toronto, you reach out to Colin Dykes. He's in this call right now. And that's the other email you sent to him, right? Again, this is mostly on the logistics, on whether, based on your targets, graduation targets, program interest, and, and your needs, how you align those things to make sure you graduate when you want to graduate. So in other words, if you have a question and you say, yeah, I want to, and you come to me and say, hey, I'm interested in cybersecurity in the context of cyber systems. What class should I take? And I may tell you, you can take this or this. Then you can talk to the academic advisors to make sure that aligns correctly with your program. You may need to file a petition. You may need to file some other type of form to make sure it aligns and basically gets, from a, perspective of viability into your degree, right? So in other words, many cases, you may say, yeah, I want to take a class in this in particular in Boston, right? Because we don't have electrical engineering in Toronto, but let's say I want to take a class in electrical engineering in Boston, and you say, well, I mean, that unless you file a petition, that's not going to apply to your degree. So in that case, you need to go to the academics advising team and say, hey, I talked to the director, he says it's fine. Then they will talk to me and we will sign a petition, right? Okay, so that's the stuff supporting your program, and that's it. And so I don't know if anybody from academic advising in Boston or Toronto want to say anything to add a little more to what I said. That would be great too. Anybody?
I'll just go quickly and I'll just introduce
Yeah.
myself really quick. Colin Dykes here out of Toronto. First of all, welcome and thanks for attending this webinar. Please reach out to me in Toronto, of course, anytime if you have any questions. We're all here to help and support you through your graduate journey.
Thank you, Colin. Okay. This is the simple down with the presentation. Let me see. I see a question there, so let me see the first question. Can you explain the difference between the MS Electrical and Computer Engineering program with the communications and concentration and the telecommunication network program? What kind of subject? Okay, so that's an excellent question, Parmar. So this program is the telecommunications network program, right? So this is an industry-oriented program in which our big focus, as I said, is on the protocols, technologies, and standards that you need to build systems. The electrical engineering, the ECE program is a program that runs within the College of Engineering. So we are within the same structure, but it's on the electrical engineering division, right? And their focus is more on the academia side. So let's say you're interested in going for a PhD, that's the program you need to go. Right, so you want to get a master's in electrical engineering from the ECE department if you're planning to go for a PhD, because it has the fundamentals to model systems and do the mathematical modeling in such a way that you have those mathematical skills that you need to go for a PhD. Because in a PhD, what you do is innovative R&D, and in particular, basic research. So our program is more on the hands-on side. So this program is about you getting the skills so you can go to the industry to build telecommunication networks, not to model them. So that's the main difference, right? So again, if your goal long-term is to stay in academia and go for a PhD, the EC program is a very fit. If your goal is to go to the industry and build systems, the telecom program is a better fit. All right, that's typically the rule of thumb. That depends. That doesn't mean you cannot go for a PhD later on. We do have a few cases of students that have taken the telecom program, and in particular, if you do the project class and the thesis class, that will put you in a good shape to go for a PhD later on. But our focus is to satisfy the immediate needs of the industry, which is different than the goals of the EC program. Okay, so that's it. And I don't know if there's any other questions.
No, it doesn't look like there's any other questions. I just want to say, I'll just answer briefly because there were two students that asked about scholarship opportunities. And thank you. I see Molly also answered a student on that as well. I'm just going to put a link in our chat that just has some external awards and just other opportunities that you can look into. For the most part, the college scholarship opportunities are very limited. If you are going to attend your program in Toronto, though, you do get a 25% discount on your tuition. So for anybody going to Toronto, just be aware of that. Any other scholarships, like I said, are really, really limited, but they would be offered to you during your admission. So once you get your letter of admission, you would also be awarded your scholarship at the same time. So if that didn't happen to you, you can look at our website, and there are some external awards and some external funding you can look into that might be able to supplement your degree. But I will say, in general, most MS students do either take out loans for their degree or they use family funding. So just be aware of that while you're doing that. And it looks like we have some more questions. So there is a question about, you're an international student, but you have not received your I-20. Let me see if I can also find the student inquiry link for our Office of Global Services. So that is our OGS team. So admissions does not process your I-20. So unfortunately, we can't status update that for you, and we can't check on that for you, but I can give you their inquiry form. And you can check your status with them. Just one thing to note, OGS, unlike the College of Engineering, does work for the whole campus. So if there is a delay in response to you, that's just because they're serving the entire university. So I know things are a little crazy this time of year for them. So if they don't answer you immediately, just keep that in mind. And there's another question. What is the typical class size and student to faculty ratio in the telecom networks program?
Yeah, I can probably answer that one. So quick answer is depend on the class, but typically is no more than, I would say, 25 students per class. Within the telecom program, that's probably 20, 25. If, however, you go, and there are some exceptions, right? Like our Unix class is fairly popular, and that's a skill pretty much everybody needs. We get a lot of students outside the telecom program from that class. That's a lot bigger. But in general, for telecom, it's around 20, 25. Outside for electives in other programs, that depends on those programs, right? So if you go to classes on object-oriented programming, those are typically very, very large classes, but again, never more than 40 students. So hopefully that answers. There are some other classes are very small, right? Like 10 students. So depends anywhere between 10 and 40, with on the telecom side, more between the lower 20th, and outside telecom above 20, and depending on the popularity of how popular the class is.
Great, thank you. Yeah, so it looks like that is the end of the questions for now, unless anybody else has any questions. But before we log off, I just want to throw the mic over to our student ambassador. He didn't get to chat yet today. Do you want to say anything to the admitted students before we log off?
Yeah, hi everybody. My name is Kudzai Chimboza. I'm the graduate student ambassador for Toronto. So if any of you need to get in touch, I'm just gonna send you a link so that you guys can hopefully join us and we can talk more. Thank you.
How do you like Toronto? Can you give say a good words about Toronto?
Yeah, Toronto is quite vibrant, very exciting, multicultural, so to speak. Yeah, and I actually love the transit system. It just makes traveling easy.
That's good. Yeah, and you can say the same about Boston, right? So it's one of the few cities where you don't need a car, so you can be here, and you should be fine without a car for the rest of your life if you want to stick to Toronto. to Boston. Yeah, and Toronto probably the same. Yeah.
Yeah, sure.
You see two more questions popped up. I do see a question about FCE, so that would be foreign credential evaluation. I wouldn't be able to answer any specific questions about that on the call today, but I am going to put the admissions email address into the website, into the chat for you. Reach out to us. It's super helpful if you have it. If you reach out to us with your student ID number, that helps us help you. If you don't have it or you forgot it, don't worry about it. Just include the email address that you submitted your application with. That's also really helpful, and we can try to help you with that. Another question. Are there any specific minimum or recommended machine laptop requirements for the program? Do you have any recommendations, I guess?
Yeah, so that's another good question. So my recommendation is you don't need something super fancy. In fact, I will stick to Windows if you ask me, because it has a lot more flexibility. And I would say any i7, an Intel i7, so a computer that may be even 5 years old should do it. The biggest thing will be running virtualization, like Hyper-V, VirtualBox, OVM kind of stuff. That's it. That's as much as you're gonna need. But yeah, so that's my recommendation. Again, I will stick to Windows. Believe it or not, you have a lot more available stuff to run if you stick to Windows.
Great, thank you. Yeah, so I guess I'm not seeing any other questions. So if that's the end of the questions, I'll just say thank you everybody for joining today. If you have any other questions, please feel free to either reach out to admissions, you can reach out to our student advising team if you have registration questions. Always feel free to reach out to Rolando and our student ambassador. We're very happy to help you. And thanks again for joining us. and enjoy the rest of your day, evening, wherever you are in the world. And thank you, panelists, for joining today. Appreciate it.
Thank you, guys. Thank you.
Bye, everybody.
Welcome. Have a great day, everyone.
Thank
Thank
you.
you. Bye.